So in this part of the video, we're going to continue reviewing for the final. This is part 3, and it's going to be looking at trig identities. So first off, if this one's a matching problem, you have to match the question to the correct identity. So just as a reminder, there are 3 types of identities that we have learned. We've learned about reciprocal identities, and there are quite a few reciprocal here, but in case you have forgotten, make sure you use your handout that you were given or look back at the notes to remind yourself what are the identities. So secant reciprocal is 1 over cosine. You have cosecant, which is the reciprocal to 1 over sine. And then there is cotangent, who is the reciprocal to 1 over tangent. So those are all the identities for reciprocal. So like when I see secant here, I'm going to match it with something that has 1 over cosine. So that's probably b here. And then same thing, cosecant is the reciprocal to 1 over sine. So this is probably a here. And cotangent is right here. So perhaps cotangent is going to be 1 over tangent if there is something here. But it doesn't seem like there's 1 over tangent. So perhaps they're using something else. So the next identity that I want to mention is the quotient identity. So this is when you can represent tangent and cotangent in terms of sine and cosine. So just as a friendly reminder, tangent is always sine over cosine. And then cotangent is always cosine over sine because it's the reciprocal to tangent. So notice they're flipped. So when I see tangent here, I'm looking for something that's sine over cosine, so probably D. Cotangent is probably something with cosine over sine, so F. So this one could be F. All right, and then the last part identity is going to be the Pythagorean identity. And there are 3 Pythagorean identities that we'll mention here. So the first one deals with sine and cosine. So anytime sine and cosine square, it's great because it equals just 1. But if you have 1 plus tangent squared, then this actually equals secant squared. If you have something that's 1 plus cotangent squared, this is going to be equal to cosecant squared. All right, so those are the 3 Pythagorean identities. The first one we have here is sine squared. And so here's sine squared. And you can kind of see the identity doesn't have anything that looks like what we have except for this one here. So when I look at h, I start to notice this is 1 minus cosine squared, which is kind of like what we have. So notice if I were to, let's see if I can move this over just a little bit. So if I were to just subtract off the cosine here, and I would subtract it off to this side too, these would technically cancel, and I would have sine squared would be left on this side here because I've canceled this out, and I would have 1 minus cosine squared. So apparently, if I use this identity and rearrange things, I can say that sine squared is just 1 minus cosine squared. So I think this has to be h. Tangent plus 1, we can see this is a straight up identity, is just secant. So we need to find something that has a secant squared, which would be, this one's kind of tricky. I don't see a secant squared, but what I do see is 1 over cosine squared. So we learned earlier that secant is just 1 over cosine, so I think this has to be E. So even though this should be secant squared, there's not one here that says secant, but we do see one that has 1 over cosine, and it's a squared, so that also represents secant. That one's a little bit trickier. Tangent squared would have to be, let's see, if we're looking for something that is tangent squared, perhaps this would be, so it looks like we've already done A, we've already done B, we've already done D, we've already done E, we've already used F, so it looks, and we already used H. All right, so it's down to C or G. So I definitely know it can't be G because 1 over sine does not represent tangent because tangent also has a cosine. So it'd have to be probably C. So it says here this would be 1 over cotangent, so it would flip the cotangent if it's in the bottom. And tangent and cotangent are reciprocal, so this is definitely C here. Plus, anytime you have tangent, you can also write this as 1 over cotangent. So if you have tangent that is squared, like we do, you can write this as 1 over cotangent squared. So that one has to be C then. And that's it. All right, so in our next problem here, it's kind of like part D. You have to find the angles, and they're asking us to find it in terms of degrees. And so in this case, we're definitely going to need a unit circle to help us out. You can also use a calculator. I recommend also knowing how to use the calculator for your final, because some of them you can't use a unit circle. You'll have to use a calculator and use inverse trig to help you out. So if you need to review that, make sure you go back to chapter 5 and look over some of the problems that use the calculator. All right, so in part 4 here, we are finding the solving for x, or the angle, and the angle needs to be between 0 and 360. So some of these problems, you might need to try to get the trig by itself, and you might need to use factoring skills to help you out, as it says here. So like this one here, I noticed that this cosine square, the middle has a cosine, and this one is a 2, so perhaps using parentheses to help us factor, the side being 0. So the only two numbers that multiply to give you 2 is 2 and 1. So I know this has to be 2 and 1. I know I have to have cosines down. So perhaps I'll make these both plus signs. And let's see if this works. So 2 times 1 is 2. 2 plus 1 is 3. So this type of factoring does work. And then I'll set each one equal to 0. And when I do this, I have to get cosine by itself. So factoring is great because it brings down the power. And once you bring down the power, you're able to get the cosine by itself more easily. So I would have to just subtract over 2 with this one, subtract over 1. So my cosine is equal to negative 2, and cosine is equal to negative 1. So if I were to plug this into the calculator, I would have to do inverse cosine and cancel this part out. So x comes down, and I have to plug in inverse cosine negative 2. And I would do the inverse cosine on this side. Now this side I probably don't need to take an inverse and plug this into the calculator, because I probably can find this on the unit circle. In fact, I probably won't use the calculator, but you could plug this in and see what the calculator gives you. Make sure you're in degrees when you're putting this in the calculator. So I've used inverse to help cancel out the cosine and then type this in the calculator. So you could do that. Or just use the unit circle. So I'm going to grab my unit circle here real quick. There we go. So if I look at my unit circle here, I'm trying to find where does this equal negative 1 for cosine. So negative 1 for cosine. Cosine, remember, is the x value. So there's the negative 1 that I'm looking for. Let me blow this up a little bit. You guys probably cannot see. So we can see cosine is negative 1 right here for the x value. And that's going to be at 180. So I know 180 works. But I don't see anywhere else where x is negative 1. If you guys can see it, let me know. But I don't really see any other negative 1s out there for x. So it looks like x for this one can only be 180 degrees. And then this one's really fishy. If you throw this in the calculator, cosine inverse of negative 2, you'll get an error. And you should get an error. Because one of the things we learned is that cosine has a range. And the range, where the angle, let me write here, the range for cosine is always between negative 1 and 1. So is sine. So sine can only be from negative 1 and 1, whereas tangent can be any number. Tangent can be any number from negative infinity to positive infinity. But for sine and cosine, you can't have a value inside of the inverse. So you can't have like a cosine value of negative 2. Because it's outside of negative 1 and 1. It's too big, or too negative. So this one would give no solution. Or your calculator would throw you an error. So this is the only solution that we would be able to find. So that one's kind of tricky. This one here has a two terms and they both have sign. So perhaps we can factor out a sign from each one of them since they both have a sign, but this one's only signed to the first power. So if I factor out a sign, I have to figure out what do I leave behind. So I'll bring down the minus sign, I'll bring down the equal sign and 0. So if I take out one sign from here, that means I leave behind a sign. Because sign times sign is sign squared. If I take out a sign from here, that means I have a 2 left on the inside. And from here, I would set this equal to 0 and set the other factor equal to 0. So the goal is to try to factor if I can, especially when you have like something that's squared. And so if I set them both equal to 0, this one I can already go ahead and find. I'm trying to find when sine equals 0. So when y equals 0, that is going to be down here. Notice how y is 0 here at 180 degrees. And I think sine is 0 actually right here as well. So notice the y is 0. So it's 0 at 0 degrees. This one I would have to add 2 to both sides. So that would cancel. And my sine would be equal to positive 2, which cannot, I think I forgot my x. Let me move down my x. So this sine is equal to 2. And we just said a moment ago that sine only has a range between -1 and 1. And so this 2 is out of the bounds. So, or out of range. So this has no solution. So my only two solutions here are 180 and 0 degrees. All right, and our last problem here, we have something very similar to, the problem we had previously. They both have two terms, they both have cosine, so maybe I'll factor out a cosine. So I'll factor out a cosine of 1, bring down the plus sign. So this one, I only took out one cosine, so there's still a cosine left and there's still a 3 left. Because notice if I were to redistribute cosine times 3 cosine, would give me 3 cosine squared. This one, I took away the cosine, so there's still a 5 left. So I'm going to set each factor equal to 0. So I'm going to set the cosine equal to 0 and the 3 cosine x plus 5 equal to 0. Now from here, this one I'm looking for when cosine is equal to 0. So that's the x value that equals 0. So that would be here. Notice the x is 0 here at 90 degrees. And down here, yep. So down here, the x is also 0 degrees, so that's at 270. And then I think that's it for cosine being 0. For this one, I need to subtract over 5, but I already have a feeling that this one won't work out because I'm already starting to notice the numbers are really big or bigger than 1. So cosine is equal to -5 over 3. So when I see this value here, -5 over 3 is about -1.66, which is out of range here. So in this case, I already know that this would probably be no solution. But if you want to go ahead and check that with your calculator, you can. So this would be my final answer. Just 90 degrees and 270 degrees. So that is it for this review. Definitely make sure to look over this review, try out as many problems as possible. I even also recommend looking back at your notes for chapter 5. I really highly recommend that if you're studying for this final. So it's all over chapter 5 stuff, and it'd be really good to look at the previous notes and the review sheet. And then that's pretty much it for preparing for the final. All right, I hope this helped. Let me know if you guys have any questions. Feel free to email your teachers. Bye, guys.